Hi, guys, welcome back to my channel. Please share and subscribe my channel to get more interesting topic. Thanks.
Hi guys, how are you? Welcome to my channel. Today's discussion is pipeline dapping or coating. So this is a very important subject for the pipeline industry, for cross-cutting pipeline. Uh, so today we'll discuss the heat shrinkable sleeve technology. What are the material and how it is used in the pipe and what is the process. Now we'll go the first. What is heat shrinkable sleeve? What is this? So a heat shrinkable sleeve, why it is tail like this? Means the sleeve is there, when you are heat it will be shrinkable. It will be shrinkage. In the original condition it will become and it will be adhesive. There will be adhesive there and heat shrinkable sleeve will come in adhesive and it will be bonded. So this commonly known as shrink sleeve is a corrosion protective coating for pipeline in the form of wraparound. It is a wraparound. How it will be formed? It will be wrapping. You have to wrapping the pipe and it will be corrosion protective coating. So this will be discussed how it will be wrapping everything. So this is the basic concept. Heat sinkable sleeve is corrosion protective coating for pipeline in the form of wraparound. Now, heat sinkable sleeve just that heat them up and they shrink, or more correctly they recover in length. Means there is a heat them up, you have to heat in the certain temperature and after that they shrink and more correctly they recover in length. Heat sinkable sleeve, what are the metals in there? Heat sinkable sleeve start out with a thick extruded polyolefin sheet. So this heat sinkable sleeve is comes from the polyolefin sheet. So what is polyolefin? It is the polyethylene or polypropylene that is formulated to be cross-linkable. So now it's a comes under cross-linkable. What is cross-linkable? I will give the one picture. What is cross-linkable in the next one to page. So first you have to know this is heat sinkable sleeve. It comes from the extruded polyolefin sheet. After extruding the sheet, we have to extrude the thick sheet, then it is taken to the beam where it passed under unit that subject the sheet the electron irradiation, that is called the cross linkable. So when you are seeing this thick sheet to the beam, the radiation center, the beam where it is passed, it will be passed under a unit that subject that feed the electron radiation. Then electron radiation is called the cross-linkable. The irradiation process cross-links the polyolefin. So that irradiation process cross-link and it will become the polyolefin. This improves the molecular structure such that the polyolefin will work as part of heat sinkable sleeve and provide the required level of mechanical protection while in service. It makes the polyolefin perform more like a tough, heat-resistant elastic metal or rubber rather than like a plastic metal or sleeve that field applied. So this is not only used for the pipeline coating. You have to use from the electrical appearance on electrical tube, and somewhere you have can use the fittings of the your home appliance fittings. You can use the heat sinkable sleeve. So then heat sinkable sleeve, there is the adhesive is there. After heat sinkable, beyond the heat sinkable sleeve, you have to put the adhesive. Just we have to give the basic idea what are the adhesive are there and what are the adhesive what are used for. And adhesive is them applied to the sheet and the various manufactured use proprietary techniques depending on the type, viscosity, melting temperature of the adhesive. So adhesive is used that depend upon the type, which type, viscosity and melting temperature of the adhesive. The adhesive is the key of the ultimate performance of the installation system. This adhesive is very important to wrapping the sleeve. The adhesive is very important, which is why different adhesive type will be specified in the depending on the pipeline operation condition. That's why various different condition in the depends upon the condition we are using the adhesive type. The adhesive has many functions, like it adheres the installed sleeve to the install at the coating, cutback and mainline cutting. It resists shear force Its shear force is resist imparted by soil pressure. If it is soil pressure, that resist shear force will be there, and it will be resist. After the pipeline is built and provide long-term corrosion protection to the steel, the choice of which adhesive to use is based on the pipeline design and operating conditions. So depends upon the after the pipeline period, it depends upon the choice which adhesive we have to use. It depends upon the pipeline design and operating condition. So as an example, I am giving one example. If you go the small diameter pipe flow lines operating at ambient temperature, it is operating at ambient temperature, a soft mastic based adhesive may be chosen. So there will be mastic based adhesive you can choose. But if you go the large diameter pipeline operating at higher temperature, you cannot use the mastic based adhesive. You have to use the semi crystallizing hot melt adhesive is have to use. This adhesive need to be chosen based on the corrosion protection properties. So hot melt adhesive we have to use, or mastic based adhesive depends upon the one is small diameter, another is large diameter. Another is the corrosion protection properties. Which corrosion protection properties you have to in your design. So you have to use for that basis hot melt or mastic based adhesive. The coated sheet is then cut. After finish this one, then you have to coated sheet is cut into individual sleeve. Individual sleeve depends upon the pipe diameter you have to cut, so it's suitable for application on a pipeline. So this is two basic concept you have to understand. First is the what is heat sinkable sleeve, another is the adhesive details for heat sinkable sleeve. Now we will discuss for this subject specification, surface preparation, application, quality control. These things we will discuss. Now to prevent corrosion, coating what do we have? A pipeline have a corrosion. So when you are doing the coating, that coating should have what? High electrical resistance. If there is a electrical shock will be there, then you have to resist, then coating should have that resistance. Low permeability to hydrogen and oxygen, there should not be any more permeability hydrogen oxygen, then will be corrosion will become. So low permeability to hydrogen and oxygen, mechanical strength should be there, and chemical stability should be there. So these four things are to prevent corrosion coating should have. Now we discuss that the first phase, the cross-linking. The irradiation cross-linking means the sleeve, the polyolefin, it will go to the irradiation for cross-linking. High energy electrons are used to strike the molecules at the CH bond. So there is a high energy electron should be used, the beam. This is called high energy electron used to strike the molecules. So there is a molecule at their CH bond. Then high energy electron, what will happen? To strike the molecules. After that, the hydrogen atom is set free, leaving the parent carbon atom in the free radicals. You can see here. This is the polyolefin before. This is the first is the polyolefin. After the irradiation processing, what will happen? The hydrogen atom is set free living. Then hydrogen atom is set. You see, hydrogen atom is set to free living to carbon as a free radical. As a free radical. You see, free radical. This is all the free radical. There is a no bonding is here. But it is the irradiation cross-linking. The hydrogen atom, what will happen? Hydrogen atom is free leaving, the parent carbon atom is free radical. But in the same adjacent side, what will happen? One is free radical, another is the free radicals use their energy to form a chemical bond. There is a free radical, this free radical use their energy, the adjacent side to the carbon to carbon. You see here the chemical bond is there coming. So this bond is called the crosslink. So this is the polyolefin crosslink. This is very important how it is using and how it is working in this polyolefin material. So this is the polyolefin crosslink. This is the polyolefin weapon. When the irradiation process, the beam electron being strike in the carbon hydrogen atom, then it will happen like this. One is the free radical. One is the free radical, another is their energy is comes to the carbon to carbon, there is a chem bonding is there. This bond is called the cross-linking. Now properties of cross-link backing. So what are the cross-link baking properties? Impact elastic memory. The means elastic memory impacts. Means there is a certain observe, the observe is there, maybe it should be elastic, absorb will be there, the elastic memory will be good. Increases tensile strength will be good. Increases the impact resistance, there is a certain impact, the resistance increases the aberration resistance, increase the insulation value. These are the 5 properties for this crosslink. Why we are crosslink properties? The properties of the crosslink, these 5. What are the design criteria for polyolefin? Ultimate performance dependent upon installation and surface preparation. So this is the ultimate performance depend on the installer. If you have to, when you are installing and surface preparation, is ultimate performance will be given. It depends upon how you install and the surface preparation. Install surface preparation is a very important to wrapping the coating. To wrapping your sleeve, this is very important the surface preparation. Installation is typically more critical with more demanding performance in service. But if the service is more demanding, then installation also is very typically more critical. Ideal shrink sleeve can be installed in the hard sets of the climate of the unskilled labor and is sensitive to pipe surface contamination. So, if you use shrink sleeve, can be installed. It's any people in the by unskilled labor you can install, but it is very sensitive to pipe surface contamination. If it is not good labor you are using there, it is insensitive. There is a sensitive to pipe surface contamination. Contamination may become. So heat sinkable sleeve system. What are the systems are there? Sleeve consists of baking and adhesive. So sleeve there is a consist two things. One is baking. Sleeve on its backing and its adhesive, means there is a backing, then the beyond the backing the adhesive. The backing needs to be cross-linked in order to the heat sinkable. So these are already discussed. This polyolefin is already cross-linked to heat sinkable. The adhesive has several functions: corrosion protection, wear resistance, long-term adhesion to the steel, and bond to the coating. Then adhesive. So what are the adhesive function? Corrosion protection, wear resistance, long-term adhesion to the steel. So there is an adhesion to the steel plus the your wrapping steel polyolefin. So there is a good bond to the coating. So coating bond is mainly coating bond. How will the wrapping will be bond with this primer or the pipe? So this is very important. Design of the baking and adhesive dictates performance at the operating temperature. You see heat sinkable system how it is looks like. One is the optional epoxy primer. This is the optional epoxy primer is there, and this is the adhesive. You see the white one. This is the adhesive, and this is the separate closure. So this is the cross-link baking. This is the cross-link baking. This is the adhesive, and this is the epoxy primer. So these three things is very important. Must be compatible with the mainline coating. So this is you have to choose the must be compatible with the mainline coating. So mainline coating is there. This coating and this coating should be compatible. You have to approve before the start of this wrapping coating, means by applying HSS Sleeve coating to the client. Polyolefin support. Provide the mechanical protection. What will happen? Provide the mechanical protection while assisting in the bonding the adhesive with hoop stresses provided by the elastic memory. So provides the mechanical protection. It is polyolefin. What will happen? Polyolefin. Why this is using polyolefin support? What support? They are giving the mechanical protection while assisting in the bonding in the adhesive with loop stress provided to the elastic memory. Must withstand excessive heat without splitting and melting or pinholing. So if it is excessive heat is there, then polyolefin never will happen splitting, melting or pinholing. Now adhesive, what are the adhesive we are using? Must be sensitive to the surface preparation and preheating limitation. So this is must be sensitive to the surface preparation. And preheating limitation, provide an effective bond to steel. Adhesive, what will provide? What they provide? An effective bond to the steel, and there is a adhesive should be good bonding to proper bonding with the wrapping coating, adhesive, primer, and steel. Must bond to the adjacent coating, critical to know the coating compatibility. So you have to check the mainline coating compatibility, and the must bond to the adjacent coating is the same. Provide good cathodic disbondment resistance, resist soil stress and pipe movement. So resist also, this adhesive should resist the soil stress and pipe movement. So this is also resist the soil stress and the pipe movement. Selecting the sleeve. How will selecting the sleeve? Selecting the sleeve, what is the factor? Pipe operating temperature, pipe coating type, cardback distance, outside pipe diameter, adverse soil condition, pipe laying method, climate conditions, recommended pipe preparation, and mechanical resistance class. These are the selecting the sleeve. These are the most important things to select the sleeve. Pipe operating temperature, pipe coating type, which operating temperature we are using at the site. So in that basis we have to use the check the which sleeve can use. Pipe coating type, which coating type, cardback distance, outside pipe diameter, adverse soil conditions, pipe laying method. So all these are the factors to selecting the sleeve. So hot melts and mastics. What are the differences between? Precise melt point, preheat temperature is critical. The melt point and preheat temperature is very critical. Anchor pattern and surface preparation are critical. Ensure that the higher preheat temperature does not damage the mainline coating. Excuse me 1 minute. Precise melt point, preheat temperature is critical. Anchor pattern and surface preparation are critical. Ensure that higher preheat temperature does not damage mainline coating. Mastics more forgiving in the flint under extreme condition. So mastic is the more forgiving the field under extreme condition. Tackiness and pressure sensitive nature of mastics allow good performance with less than perfect surface preparation. So this is the precise melt point. Preheat temperature is critical, very critical. Anchor pattern, surface preparation are critical. Also here in the hot melts, and ensure that higher preheat temperature does not damage. If it is higher temperature, is the preheat temperature, it should not be damage the coating. So mastic more forgiving the field under extreme condition. So mastic is more forgiving condition, most forgiving the field under extreme condition. So this is the different hot melts and mastic. I already explained hot melts and mastic where we can use, and in for what are the factors are there. What is important to install? Surface, suitable surface preparation. It is important, very important for surface preparation. Use the proper tool. Proper tool should be there and should be calibrated. Primary application, if used, and achieve the correct preheat. Preheat should be achieve the correct. It should be checked by the infrared. Flip centered on the cardback. Sleeve should be centered on the cardback. It should be centering. Correct overlap of the coating should be overlapping as per the design and the procedure. Closure properly installed. Closure should be installed properly. Correct procedure for shrinking. Shrinking, there is a procedure is there, and you have to use that procedure. Visual inspection and field test and holiday detection. So these are the important to install. When you are installing, this will be the very important factor you have to check. Now Wraparound two-layer sleeve. Two-layer sleeve, how it is looks like. One is the hot melt. It is not there is a blasting, no cleaning. Installing directly on clean and dried pipe surface. So it is a clean and dried pipe surface. First you have to give mastic layer, and after that you have to give the hot shrinkable blacking. So installation directly on the clean and dried pipe surface, compatible with standard commercial mill applied coating, no primer required. So this is the Wraparound two-layer sleeve we can use. It's the cleaning on the your main pipe, only clean, no bus cleaning. Then you have to use the mastic or adhesive or the hot melts. After that you have to use the heat sinkable backing. You can see here the preheat the surface area. First preheat the surface area, what preheating. Then you have to center and loosely dab sleeve around your center. You have to center first. First, this is the center, how it is overlapping and what are the overlapping and the center of the sleeve and around the joint. Applying one end of sleeve, applying, this is the applying one end sleeve, this is the heat is applying. When you are heating the sleeve, and it will be shrinkage and it will be adhesive, it will be bonded with your main pipeline coating. Flash addition and bring back other half of the slab. So flash addition. So this is the first is the one side is finished. When you are finishing the second side at the end, flash adhesive the bring, you have to adhesive the, this is the inside of the sleeve. You have to baking this. This is the sleeve. You have to heating the sleeve, and after that bring back other half of the sleeve. Secure closure strip by heating. Secure closure strip by heating. So you have to heating the closure strip properly at the correct temperature, and you have to secure the closure is completely done. And you see permanent change indicator, how it is dimples are gone after proper heating. That's the dimples. This is the dimples. When you are heating, the dimples are gone. Shrink from center to 160 degrees. So you are heating like this. So there is a permanent change indicator, dimples are gone proper. How we can identify? Now this is the two layer. The three layer, it is around three layer surface. What will happen? First will become the epoxy primer and the superior bonding and the chemical resistance. For the superior bonding chemical resistance, after the adhesive, this is maybe hot melt or the mastic layer after the epoxy, after the heat sinkable sleeve. So this is the only two layer, and the three layer only different is the primer application. This is the primer application is added in the three layer surface. So superior cathodic bondment, superior high temperature performance, low preheat reformant. Now we'll give the picture how it is the field joint coating where need to be done. This is you have to done by here, and this is the blasting cleaning ongoing. After that hot melt mastic application, it is the hot melt mastic application is going on. After the HSS application with proper heating. So this is the three layer surface that's giving one picture, so it will be clear for you all people. This is the now you understand for the first beginning the how it is the HSS sleeve application, 2 wraparound, 3 wraparound, and what are the metals are used and what are the basic principle of the polyolefin. So I think you are all people understandable. Thank you again. So please share and subscribe my channel to get regular video with interesting topic. Don't forget to share and subscribe my channel. And you can go through my below link here, and you can go also my channel. There is a subscribe button, and you can subscribe, and you can see you can see inside my channel so many videos are there. It will be very helpful for you people. Thanks a lot again.